In these lectures, we are going to explain the general structure of a digital computer. So again, we now look in a general way at the internal structure of a computer. So here we begin with a traditional computer with a single processor that employs a microprogram control unit. Then also examine a typical multi-core structure. The diagram here provides an hierarchy view of the internal structure of a traditional single processing computer. Here we have four main units. In every computer, there are four main units. We have the central processing unit, the main memory, the input and output, and also the system interconnections. So again, in our first circle here, we have the computer main unit, or I'll say the main structure component of a computer is the input, output, main memory, system, bus, and also the CPU. Then within the CPU, we have a register, which again, we shall go detail on it. A register normally is a memory that holds the data that is being processed in a CPU. Also, the CPU have arithmetic logic units, which perform most of the arithmetic and logical operations. Then we have the control unit. The control unit normally will be the coordinator of the system. So the control unit here does the sequencing logic. And also we have the control unit registers and decoders. And also we have the control, again, memory. So again, as we said, there are four main structural components of the computer. From our previous slides, we saw the diagram. So first, the central processing unit, which again controls the operation of the computer and perform its data processing functions, often again simply known as again processor. Then we have the main memory, which stores the data. We also have the input and output module, which moves data between the computer and its external environment. Also, we have the system interconnection. So some mechanism that again provides for communication among the CPU, the main memory, and also the input and output module. So a common example of a system interconnection is by means of a system bus, which consists of a number of conducting wires to which all the components or other elements are connected together. So the most interesting and also some ways that most complex component is the CPU. Again, the CPU is the most interesting and in some ways the most complex component in a computer system. Its major structural components shown here consists of, as we said, the control unit, also the arithmetic and logic unit, the registers, and the CPU interconnection. So as we said again, control unit will control the operation of the CPU and hence the computer. And also the arithmetic logic unit perform the computer data processing functions, such as again, the arithmetic operations and also logical decisions. And the registers provide again storage internal to the CPU. So normally the registers will hold the data or instructions that the CPU is executing. Then we have the CPU interconnection, which as we said is some mechanism that provide for communication among the control unit, arithmetic logic unit, and also the registers. Now next we discuss about what is a multi-core computer structure. And first, we know that the contemporary computers generally have multiple processors. So when these processors reside on a single chip, we use the term a multi-core computer. And each processing unit, which normally consists of a control unit, arithmetic logic unit, and the registers, and also perhaps a cache, is normally called a core. So to clarify the terminology, again, our textbook will use the following term, and the central processing unit, that will be the portion of computer that fetches and executes instructions. Also, it consists of an ALU, the control unit, and also the registers. Now, the core will be an individual processing unit on a processor chip. So a core may be equivalent in functionality to a CPU on a single CPU system. Also, other specialized processing units, such as the one optimized for vector and matrix operation, are also referred to as a core. So a processor, as we said on the slide, is a physical piece of silicon containing one or more cores. So a processor is a computer component that interprets and also executes instructions. If a processor contains multiple cores, then we will use the term again, multi-core processor. Next will be the cache. So another prominent feature of any contemporary computer is the use of multiple layers of memory, called a cache memory. And this will be between the processor and the main memory. Normally, in a typical computer system, we may have level 1, level 2, level 3 caches. Level 1 cache will be the most fastest cache, which is again closer to the CPU. So that will be the fastest. And also it's less capacity in terms of storage. Level 2 still is close to the CPU, but not as level 1. And the same thing applies to level 3. And so level 1 will be bigger and a little bit far from level 1. Level 3 will be more bigger than level 2 and far from the CPU compared to level 1 and 2 progressively. So this diagram again is simplified the view of the principal component of a typical multi-core computer. Most computers, including embedded computers in smartphones and tablets, plus again personal computers, laptops, and workstations, they are all housed on a motherboard. So before describing this arrangement, again, we need to define some terms. First, what is a printed circuit board or PCB? A printed circuit board is a rigid, flat board that holds and also interconnects chips and other electronic components. So normally this board is made of layers, typically 2 to 10, that interconnect components through copper pathways that are etched into the board. So here we can see that the main printed circuit board in a computer is called a system board, or again, we use the term motherboard. So with the motherboard normally consists of all the components and they are connected together. Example, we have the processor chip, input and output chips, the main memory, etc. So the motherboard normally contains a slot or a socket for the processor chips, which typically contains multiple individual cores in what's again is known as again multi-core processor. So for desktop computers, expansion slots enable the inclusion of more components on expansion boards. So again, the diagram shows a processor chip that contains 8 cores. So we have a processor chip. We can see the cores. We have 4 at the top, 4 at the down. Then we have level 3 caches between. So we have again 8 cores and 2 level 3 cache. Again, not shown is the logic required to control the operations between the cores and also the cache, and between the cores and also the external circuitry on the motherboard. So again, this will be the conclusion of these lectures. And in these lectures, again, we just went through the basic component, again, for a computer, a typical computer system. Also, for example, we have instruction logic, which include the tasks involved in fetching instructions and decoding each instruction to determine the instruction operations, and also the memory locations of any operand. So again, these lectures, we went through what is arithmetic logic unit, what is a register, etc. So again, see you in the next lectures. Thank you.